Good afternoon, everybody. In the last lecture, we have learned some part of radiation source. In that tungsten filament lamp, we have learned tungsten filament lamp is mostly used as a radiation source in visible region, but there are some limitations because tungsten filament lamp give rise to the radiation in mostly 90% radiation in IR region. So that is the limitation of tungsten filament lamp. Now, as a radiation source in any type of photometry, discharge lamps are employed. Now, there are some advantages of discharge lamps also. So, hydrogen discharge lamp, deuterium discharge lamp, mercury discharge lamp, xenon discharge lamps. These are the lamps used as a in any type of photometry in UV visible region, especially ultraviolet region. Now construction. If we look this, if we focus on the construction, then we will find that any type of discharge consists of a quartz tube fitted with 2 electrodes at the end of the tube. At the bottom, there are 2 electrodes are placed, and it is filled with respective gas at low pressure, that is near about 0.2% torr. So that is a pressure that should be present in the system of the quartz. Now here, any type of discharge lamps are employed, and 2 electrodes are placed at the bottom of the quartz tube. And it is most important that if the xenon lamps are used, then the gas must be xenon gas. If hydrogen gas we can use, then hydrogen discharge lamp we use, then it should be that quartz tube should be filled with hydrogen gas. If deuterium discharge lamps we use, then deuterium we fill the deuterium gas in the quartz tube. So these are nothing but that is, you can say, specification related to the any type of discharge lamps. So working, when the low voltage is applied across the electrodes, then the discharge of electrode takes place, which on striking with gas molecules or atoms emit the electromagnetic radiation in ultraviolet and visible region. So whenever the low voltage, or you can say any type of voltage, is applied across the electrodes, then there is a discharge of electrode takes place, and this discharge of electrode give rise to the electrons. Now these electrons emits everywhere, and they strike the surface of any gas atom or gas moiety or gas atom present in that tube, and finally this will give rise to the electromagnetic radiation, because when electron get absorbed by the gas molecules, they will be excited. The excited species of gas atoms or molecules come down to the ground state with the liberation of can say electromagnetic radiation. So that is, we can say, working principle of the any type of discharge lamps. Hydrogen emits a radiation of 120 to 530 nanometer. So hydrogen discharge lamps emits the radiation in visible and ultraviolet region, that is 120 to 530 nanometer. The wavelength of deuterium is same, as hydrogen is the isotope of deuterium or deuterium is the isotope of hydrogen, then the wavelength must be the same, but the intensity will be increased with 3 to 5 times. That is, you can say, the intense deuterium lamp is more intense than the hydrogen one. Xenon discharge lamps emits the more intense radiation than any other discharge lamps. So intensity, if we consider the intensity, liberation of intensity, xenon give rise to the higher or more intense spectra of wavelength in the rather than the hydrogen and deuterium lamp. So that is, we can say, all about the discharge lamps associated with the any type of photometry. So this will be the typical diagram Now this diagram is you can say mercury vapor lamp. This diagram is nothing but it is a mercury vapor lamp. So these are the two electrodes. One is auxiliary and another is cathode. Now there is a, you can say, when the voltage is applied, at that time electrons will be liberated, and these electrons get captured with by the species present here, and that species are nothing but the vapors, or you can say any type of gas molecules. If the xenon discharge lamps, then it should that gas will be filled with xenon. So with liberation of that gas molecules will be excited, and these excited species come down to ground state with liberation of radiation, and they come down with in the region of ultraviolet and visible region. So that is, you can say, most important about the fact related to the discharge lamps. Now, what should be the ideal source or radiation source? What should be the characteristics or properties of related to a light source? That light source should be stable. First condition is that the light source should be stable. Now, second one, it must supply the continuous radiation. It must supply the continuous radiation. And third one, it must produce sufficient amount of intensity so that transmitted radiation get detected. So for the use of transmitted radiation to be detected, that radiation source should produce such a type of intensity with the help of that we can easily capture the transmitted radiation intensity. So that is all about the discharge lamps associated with the radiation source. With this content, I conclude this lecture. Thank you very much for patience listening.